My name is Anand Parvin. I'm working as a PhD student in physics area. My research title is that clean cement water using the recycled glass powder. So nowadays, construction industry are facing sustainability and economy, because how can you define the sustainability? So meanwhile, recycling and reuse is the most important thing to use to save the natural resources, to save the landfill. So for example, in the United States, 2010 years, 11.5 million ton glass was generated. Only 27% glass was recycled. If we think and say 2012, it was the 13 million glass was generated. And only 27% glass was recycled. So and then remaining thing we are sending to the landfill. So here the sustainability. How can we define the sustainability? So without compromising any future resources. So here, if we think about that, the production of the 1 ton of cement is generating the 1 ton of carbon dioxide in the atmosphere. So this is the sustainability. So we are using the recycled waste glass in the cement replacement material. So main objective is there. So non-recycled glass we use as a cement replacement material. So these are the all that objective is there and scope of the materials there, and then experimental procedure. So materials and methodology. So materials is there of ordinary Portland cement, fly ash, silica foam, sterile butadiene rubber, and sand, and super plasticizer and water. So these are the material. Mixing of material. Test property includes the floatable test, another the preparation of the specimen and the curing. Next one, the physical and mechanical property and durability property. Physical property includes compressive strength, flexural strength, and density and water absorption test. Durability property includes that the alkali silica reaction, because once you use that glass, so it has the alkali silica reaction problem. So we need to test for the durability point of view, and then research and discussion. So if we see the floatable stress, so it's decreasing the value. So it has a very good flowing property and very good pozzolanic reactive activity. So that is good, and it's giving the above the 200 value is above the 200. That is good. Compressive strength is also increasing. If you see the compressive strength, so this is one only glass. So this experimental program was divided into 4 series A, B, C and D. In series A, so we have given the 5 to 25% glass. Series B, we have used 10% fly ash, 10% silica fume and 10% sterile butadiene rubber. So in all the series, so compressive strength is increasing, as well as flexural strength is also increasing. So this is the mechanical property. In physical property, there is the bulk density and water absorption. Bulk density is increasing and that water absorption is reducing. So that is very, very good. And alkali silica reaction, so it has a less water expansion, it's below the 10%. So it is the desirable. So it's based on the American standard ASTM 1260. It's below the 10%. There will not be any adverse effect for the concrete. And then we found that so the mix D is the optimum mix proportion. So 25% glass is better. So these all are the materials. So how I have used, so you can have a look. So these are the glass powder, silica fume, fly ash. You can have any questions. So I am very happy to answer. Yes, yeah. So I can explain. So these are the ordinary Portland cement. This is the ordinary Portland cement. This is the silica fume, that is also waste product. This is the fly ash, that is also waste product. And this is the glass powder. That glass powder I have collected from Glenmore landfill site. Then I crushed manually. I crushed a very ultra fine particle, so it's near about below the 75 micron. Then when I use as a cement replacement material, so I use as a up to 5 to 25% cement replacement material. And if we use the only glass, so there will be anxiety for the expansion. So I test for the expansion test also. So this is for mortar bar test, and I studied how much the expansion. So all the expansion is below the 10%. All the expansion is below the 10%. So 10% is desirable. There will not be any adverse effect. As per the American Society of Testing Material 1260. This is for compressive strength, I did apply the compressive strength like this one and studied what the compressive strength. So if we think about here, so control motor is giving the 40 MPa strength. So this is the glass control motor, but if it is the series B, it's giving the 85 MPa strength. Strength is double here. Strength is double. We are reducing the cement consumption near about 60 to 70%. So that's why it's called sustainable. We are reducing the cement consumption 60 to 70%, and we are increasing the strength double. So it's giving 40 MPa. Here we are with 85 MPa, double strength. So that's why it's called green sustainable material. So how we can define? So that is called sustainability. So we are reducing the environmental resources, and we are reducing the landfill, because if we are generating 1 ton of cement, we are generating 1 ton of carbon dioxide in the atmosphere. Global production of the cement throughout the world is 2.8 billion ton. So if we are producing 1 ton of cement, so we are generating the same amount of carbon dioxide in the atmosphere. So we are generating 2.8 billion ton carbon dioxide in the atmosphere. So we are reducing the carbon footprint here. 70% cement consumption we are decreasing. We are increasing the strength. There will be no any adverse effect for durability point of view. Physical property is also good. Mechanical property is also good. So all aspect is good. We are reducing 70% of cement. So that is the most important.
Thank you, Anand. That's all the time we have for this poster. So.